Hello students, welcome to the channel Physics for IITians, where we learn physics, understand physics to crack interviews of PhD and integrated PhD interviews. In this lecture, we'll discuss about scattering of light. So, today we'll briefly understand what is the scattering theory of light and how it was discovered and what is its application in real life phenomena or real life examples. So, scattering is a phenomena of light when light is propagating through a medium. Okay, so we know that from the light matter interaction, when light interacts with matter, the light can be reflected or it can get transmitted or it can be absorbed inside the medium depending on the optical properties of the medium. So today we will talk about the scattering and what is the meaning of scattering. So scattering is the transmission of light in all direction, right? So it can be omnidirectional. It could be any of the direction because reflection is a directional, refraction is also directional, but mostly general term of to represent these things is the scattering, which is directed in 360 degree. So when it was observed first, so Tyndall observed that when a beam of light passes through a transparent object, so let's have some transparent liquid object and light is incident on the object and it is passes through the object, then the transparent objects have some particles and these particles can scatter the light in all directions. So light gets scattered. And the scattering of light initially was assumed from the tiny particles uh, composed in the material. But later, Lord Rayleigh, who proposed that this scattering of light is not only is a phenomena of the scattering from the small particles. Okay, it's not only the particles, it's the phenomena from the electrons inside the particles. So let's see how Rayleigh proposed the theory of scattering, which is not due to the particles, it's due to the electrons or motion of the electrons present inside the molecules composed of the particles or molecules that compose the uh, whole particle. So, according to Rayleigh, the molecules are composed of ions and electrons, which is revolving around the ionic core. And when the light wave, which can be wave or which can be a photon, stream of photons or wave, is incident on the molecule, it will be polarized. The positively charged ionic core and the negative charged electrons will get distorted and it will create dipoles. And now these dipoles will be oscillatory because this incident electromagnetic field of the light is oscillatory. It could be a positive cycle for the first half of the cycle and it could be a negative cycle in the second half cycle. So according to the oscillation, the molecules will also or electrons will also oscillate. If we think the nucleus or ionic core is stationary because it is very heavy. Therefore, the electrons can oscillate with respect to the incident electromagnetic field or electromagnetic wave or light wave. And this oscillatory electric field electrons, they are accelerated charges or oscillatory charges particles, right? Charge particles. And according to the classical electromagnetic theory, uh, an oscillatory charge particle can re-radiate the frequency which it is oscillated with. So electrons are oscillated with some light frequency omega, let's say, and according to classical mechanics, since it is a charged particle, so it will re-radiate the same frequency of light omega, right? So therefore, the scattering which is incident on the molecule it is re-radiated by the molecule. And this re-radiation can be 360-degree in any direction. That's why scattering is omnidirectional. And this is the basics of Rayleigh-Jean's law, where according to the Rayleigh, he derived the equation of the uh, scattering intensity, which is proportional to 1 by lambda to the power 4. Lambda is the wavelength of the incident light or electromagnetic wave. So therefore, the lambda having higher value will less scatter, right? And lambda having lower value will more scatter. So lambda having lower value means like blue light. It has very less value of lambda compared to red light. So blue light can scatter more. Therefore, we see blue sky. And when the longer wavelength or like red, it scatters less and it travels more. Therefore, at the sunset, we see red color because it scattered less and it can travel more distance and it can comes to our eyes. Therefore, we see red color during the sunset. And also, red light is useful in traffic signal and also where the traveling is more crucial that the audience or the people can see the light. It should not be scattered anywhere. Therefore, we use red lights for traffic signals, ambulance light, and uh, other scenario. So the basics of scattering theory here is the Rayleigh scattering theory is the re-radiations of the electrons by classical electromagnetic theory, where says the charged particles, accelerated charged particles can emit electromagnetic radiation at the same frequency which it is on the influenced on or it is in that frequency. So the incident frequency should be the same radiation frequency. Therefore, the term is also known as re-radiation. So friends, this is a very crucial concept of scattering theory. I hope you understand the concept and this is important for interviews also. And if you want to take our interview guidance, you can join our IGP program, interview guidance program. We update everything on our website. So please have a look on our website, our Telegram channel, Physics by IITians. And also, you can contact us on our Facebook page, Physics by IITians. Please subscribe the channel and share with all the students, all the friends. Thank you.